Hello, and today's lesson we're going to be looking at identifying the gradient and the intercept from an equation rather than from a graph. And on the screen you can see two straight line graphs, one with the equation y equals 3x add 9. The intercept then is 9, which you can see here, and the gradient is 3, so a long one up 3. And then another one with the equation y equals 3x add 2. So this has got an intercept of 2, y-intercept of 2 right here, and a gradient again of 3. So for every one along, we go up 3. So these have got the same gradient, and therefore they are parallel when we draw them onto the graph. And that means that they will never intersect. So they're like what are often called train tracks, just going along with the same slope. They are never going to meet, no matter how far along those graphs we go. So that tells us if the coefficient of x is the same, then we know our two equations are for parallel lines. Okay, so what I would like you to do here is pair up these equations. These should all fall into pairs that have the same gradient and therefore pairs of parallel lines. So pause the video here and see if you can pair up these equations. Okay, so this should be your answer. So here we've got two equations with a coefficient of 3 in front of the x, so these have the same gradient, they're parallel. These ones down here, okay, the constant and the x term are in a different order, but it's the number in front of x that's important for the gradient. So these both have a 2, and therefore these are parallel. These, again, they're in a different order, but the coefficient of x in both cases is -4, so these are parallel. These here, this might say x over 2, but that is the same as a half of x. So x divided by 2 is the same as a half of x. So these have a coefficient of a half and therefore a parallel. And this has an intercept of 0 because it's plus 0, but the gradients are important here, not the intercepts, and they're both 6. This is the tricky one. So we're going to talk about this one right here and how we know that these are paired up, even though this has a -2 and this has a +2. So we can't read off a gradient or an intercept unless our equation is in the form y equals something. We've got to have y as the subject. And that was the problem with this one. So I can't read off the gradient as 2 here. That wouldn't be correct because it's not in the form y equals. So what I need to do is subtract 2x from both sides of this equation. And we're going to use all of our solving equations skills here to rearrange these equations to get them in the form y equals something. So when I subtract 2x, that means that I'm going to get rid of this 2x here, leave y on its own, but I've still got to subtract 2x from this side, and I can't actually subtract 2x from 3 because I don't know what value it takes. So I'm just going to write it as y is equal to 3 minus 2x. And now I can say that this gradient has, this equation has a gradient of -2, and that's how I knew it paired with the other one in that last exercise. Okay, moving on then. This equation here is not in the right form for us to read off the gradient and the intercept. So what I'd like you to do is pause the video here and see if you can use your solving equations skills to prove what is in the bottom left-hand corner. So you've been given the answer here. Can you show that that's true by rearranging this equation? Okay, so first of all, I need to subtract 12x from both sides so that the y's are left on their own on that left-hand side there. And that's going to give me 3y equals 6 subtract 12x. If you stopped here, that would not be correct because this still isn't y equals, it's 3y equals. So I now need to divide both sides by 3. And if I divide 3y by 3, I'm going to get y. 6 divided by 3 will give me a 2. and negative 12x divided by 3 will give me negative 4x. And now I can read off that the gradient is negative 4 and that the intercept is 0, 2. Okay, here is another example for you. Could you rearrange this equation so that you can prove the gradient is 7 and the y-intercept is 0, 6? Pause the video and give that a go. Okay, so for this one, we are just going to need to add 6 to both sides. And that's going to give me y equals 7x add 6. And from there, I can directly read off that the gradient is 7 and the intercept is 0, 6. By the way, when you are asked for the y-intercept, you shouldn't just be writing 6. If you're asked for the coordinates of the y-intercept, you do need to say 0, 6. Okay, what about this one? A little bit more tricky. Could you pause the video and see if you can work out what the gradient and the y-intercept is for this equation? Okay, right, so first of all, I'm going to subtract 11x from both sides of this equation, and that will give me 2y add 5 is equal to negative 11x. Then I'm going to subtract 5 from both sides of this equation, and that will leave me with 2y equals negative 11x, subtract 5. Still not finished though, because I've got 2y when I should have y. So finally, I'm going to divide both sides through by 2, and that's going to give me y equals, and I've written this in fractions, so negative 11 over 2x, subtract 5 over 2. And now I can read off the gradient. The gradient is going to be negative 11 over 2, and the intercept is 0, negative 5 over 2. Okay, so here is your task for today. Question 5 there, you've got lots of equations which you have got to rearrange to read off the gradient and the coordinates of the y-intercept. So remember, your coordinates for your y-intercept should always be 0 something. Must be a pair of coordinates and not just a value for y. And for question 2, you're being asked to find which pair there are exactly the same graph, so just a rearrangement of the same equation. So pause the video here and see if you can answer these questions.